This is a very different conversation compared to what we usually have. No deep dive into soil science, regenerative agriculture practices, or how to sell nutrient-dense food. Instead, we have an absolute technology expert joining us to talk about a whole suite of technologies in different families, ranging from modeling to digital twins, digital shadows, robots, and other smart hardware solutions that are so needed in our regenerative transition. But we barely started even thinking about them, let alone using them. You hear all the time AI, machine learning, large language models, but that's only a small subset of what's available to us now. And our guest of today argues we are so deep into trouble that we can't afford not to model. We can't afford not to use these technologies to build better. Better farms, better farm technologies, better robots, better hardware, better food systems, better food warehouses, and so much more. This is the Investing in Regenerative Agriculture and Food podcast, Investing as if the planet mattered, where we talk to the pioneers in the regenerative food and agriculture space to learn more on how to put our money to work to regenerate soil, people, local communities, and ecosystems while making an appropriate and fair return. Why my focus on soil and regeneration? Because so many of the pressing issues we face today have their roots in how we treat our land and our sea, grow our food, what we eat, where and consume. And it's time that we as investors, big and small, and consumers start paying much more attention to the dirt/soil underneath our feet. To make it easy for fans to support our work, we launched our membership community, and so many of you have joined us as a member. Thank you. If our work created value for you, and if you have the means, and only if you have the means, consider joining us. Find out more on gumroad.com/investing-in-regen-ag. That is gumroad.com/investing-in-regen-ag, or find the link below. Welcome to another episode. Today with technologist, innovator, inventor, and a leader in Technologist, innovator, inventor, and a leader. Welcome, Paul.
Hi, good to be here.
And first of all, a shout out to Henry Dimbleby, who put us in touch and who already mentioned you in our 2-hour-long deep dive. Don't go and listen to that now, people. I'll put a link below if you haven't listened to that yet, but mentioned digital twins and said you really, really have to talk to Paul. And here we are, and I agree. We had a pre-call and I had the pleasure of doing a bit of background research into your fascinating journey into technology and of course the world of food and agriculture. You're definitely not deep in the world of regenerative food and agriculture, but you've played a large role in moving a lot of food, like more food than most people will ever touch in their lives. And so I would love to unpack that, what you see, what you've noticed, what are the opportunities of digital twins and other deep technologies that we need, that are already there, that we might not even know how to use yet. So I'm really looking forward to that. This will be a wide-ranging interview and conversation. But first of all, starting with a personal question, in this case, how did you roll into the world of technology? I can see the background behind you, a lot of different boxes and things, probably full of cables and all kinds of things to build. But were you always like that, or how did you roll into the world of tech?
Well, I suppose as a child, when many of my contemporaries were reading kind of, Enid Blyton or books like that, I was normally reading instruction manuals for cars and things like that, and taking stuff apart and putting it together again and maybe making new things out of those parts. So I was always fascinated by how things work and how things are built, and by machines of all sorts. And so that love of how the world works kind of drove me to studying physics at university. But even then, I was fascinated by the early days of personal computers, and I nearly dropped out of my physics degree to do a first startup. But I always kind of knew that I wanted to work with computers and technology and probably within startups. And so that led me into the computer industry. And sure enough, about 2 years in, the opportunity came to do a first startup, and I grabbed it. So it's been that way from the start, and I suppose over that journey, the technologies may have changed and evolved, but many of the themes have continued, particularly the excitement of working at the interface of software and hardware systems. Things that move under software control are much more exciting than just on a screen.
And was it always the case for you, like that interface or that connection between the hardware physical world and the software world, or has that been gradually over time? Like your first startup or the first companies you worked at and with, was that predominantly the software side, or also the stuff you could touch, the hardware side? And I don't know if you were or are a foodie at all, but let's say, when did the food world enter your professional life, not just your kitchen, in your journey? And there was quite a profound one, I think, in terms of scale, in terms of technology, in terms of moving parts, in terms of especially let's say moving things that can go bad quite quickly if they are in the wrong temperature or are put on top of each other in the wrong order. It's very different from moving. I mean, probably also clothes are tricky, and a lot of other materials are tricky, but food specifically, fresh produce even more, makes it a very interesting challenge. How did that happen? How did you roll into the world of food? Or maybe it was always a dream to be working on food and agriculture.
So I suppose the place at which or the point at which I got involved in moving food was when I joined Cardo, and that kind of happened by accident. Somebody gave my name to a recruitment consultant, and they persuaded me to have a chat with somebody, and they then in turn persuaded me to go and have a look at their first generation warehouse in Hatfield. And when I stepped into that kind of Aladdin's cave of technology, I was completely blown away. It was their first generation warehouse in Hatfield, so it was conveyor based, and a long way from where the technology got to during my time.
What was so impressive when you stepped in? Like, just for people to understand, was it the noise? Was it the smell? Was it the size? Just for you, coming from what you were doing before.
So I'd had some involvement certainly with robots before that, but nothing like this. This was like a roller coaster or a theme park of food. It was boxes of groceries flying around over many kilometers of conveyor, and being if you like, controlled like trains on a track, taking the right kind of turning left and right at junctions, and eventually ending up in the back of vans. And so it was all about machines for orchestrating, if you like, that picking and packing of grocery, controlled by some very sophisticated software. And I was just blown away. I just thought, this is like the ultimate kind of train set that I've stepped into, and it was mesmerizing, and I think a few months later I joined to do a 1-year consultancy project. I ended up then joining permanently, and I ended up staying 15 years, which given the journey I had been on with startups, I was very surprised by, in a sense. It was never my game plan to do that, but it was a kind of it was a love affair with the technology, but also with the culture, of the company, which was incredibly inventive and creative, and very like what you experience in startups, and I had experienced in other startups. Even though by 2006 when I joined, it was still quite a big company, and so I think it was this blend of like technology and invention that attracted me. And during that period, I became CTO. I grew a huge technology division, and then handed that over. And then for the last 3 years, I ran the kind of advanced research side, which is, for those people listening who know organizations like ARPA, or in the UK, ARIA. It's the sort of the sharp end of the innovation spike, or the innovation factory at Ocado, and we were looking at all sorts of future potential technologies in that division that might be relevant, and applications that might be relevant to the future of the company. And then in 2020, I left, and the end of 2020, and decided that what I wanted to do was...
Right in COVID, when
well, yes, it was in the midst of COVID, which wasn't easy, but it was...
Interesting times for online retail, yeah.
Well, yes. I mean, it was an accelerant, certainly. It arguably online grocery delivery became sort of the fifth emergency service. It was something that a lot of people relied on, but also all sorts of kind of automated processes became important because of trying to keep people out of areas that were dangerous. And indeed, there was a desire for all sorts of other smart machines to help deal with the pandemic. But, one of the challenges with smart machines is that they have a different gestation cycle to...
What does that mean?
Well, as in, if you think about how a new piece of technology is ideated and then designed and created and tested and prototyped and eventually put into production, that's what I would refer to its kind of gestation cycle, as in, like a gestation cycle of an animal or a human, but software and hardware has a gestation or a life cycle and a gestation cycle. So it's, and digital technologies, software and AI and so forth, it's very different. And the digital and the physical worlds are different. And the really exciting things happen when the two come together. So you need...
Which is such an interesting point, that because I think many people underestimate... and I will put a video below of what you also did at Ocado, like how, because retail online is incredibly difficult, incredibly small margins, which is, you don't have the margins that a lot of other technology companies have. If you're mostly in the software side, it's a different world, which means you need to be super efficient and cutting edge and at scale. You need to move a lot of things very, very, very smartly. And that led to an incredible cycle of innovation from you and others as well, to how do you push the boundaries? How do you do this smarter, faster? Which 10 years ago, when we thought, or 20 years, maybe when Ocado started, online supermarket or online groceries or retail in general was more almost like picking from the supermarket itself, like the same layout, like it was basically just moving it online, which of course is not ideal, just as we're still stuck with the same typewriter letters on our laptop, which is not ideal. So just the immense innovation that has happened there by merging or by using both the hardware, the robotics, which has changed dramatically, I think, over the last years, and the incredible the sort of director software we now have to do the dances. And COVID has pushed that and pushed it to the limit, probably in certain extents. But now what do you see now with that? The possibilities we have on that on all the suite of technologies. Like it's not just digital twins, it's not just living labs, it's not just the swarms robotics you've built. Like if we, I don't know, lay of the land is maybe the wrong intro into. We're now talking in November 2024. It seems like everything is accelerating. But what do you see where those physical and non-physical will touch? Like what are exciting pieces for you? Of course, we're interested in food and ag, but I'm also just having you here to see, okay, what should we know in food and agriculture? What is exciting to you? What is interesting? What is meaningful? What is not interesting? What should we ignore in your world? Because you look so much deeper and further than I think many of us do in the food and ag space when it comes to technology.
Gosh, that's a good question, or big question. I think the first thing to say is, there is an incredible frenzy and focus, on AI at the moment, and arguably not AI in its inclusive, or its wider sense, but in large language models and generative AI. And, they're incredibly important and powerful technologies. I was on the AI Council in the UK, and helping to, be a part of a group advising government. And so, I'm a huge fan of AI in all of its flavors. And it's a much bigger toolkit, if you like, than just large language models and generative AI. But those are what is in ascendance at the moment. And that's what's kind of captivated, if you like, people's attention, including, normal people for whom AI wasn't a big part of their world, and for some it still isn't, but for many more now it is, because it's become much more accessible. So AI has had its kind of chat GPT moment. Some other technologies haven't yet. So, but the point is, it is one of the other flavors of AI is embodied AI, which is when you put that kind of intelligence, if we want to call it that, inside a machine, inside a smart machine, and it makes the machine, that's the smarts, if you like, in the smart machine, but it's a symbiotic relationship, because the smart machine also can be the arms and legs of AI. It can allow AI to escape, if you like, from inside your desktop or whatever, and or a server, and get out into the physical world and do that with scalability and agency. So smart machines, as they go around, often they're controlled or orchestrated by sort of centralized kind of AI systems, and sometimes they're autonomous. So sometimes, like autonomous vehicles or drones, they're able to perform
without
minute-to-minute control. They probably still need some degree of orchestration, because they need to know what you want them to do. But it's a blend of the two. And so now we've got AI, and now we've got smart machines, and then the third member of the holy trinity, if you like, is what I would call synthetic environments. So synthetic environments is another family like AI. And in fact, another family like smart machines, because there are many different kinds of smart machines. It's probably worth, before going on synthetic environments, just to point out that, you often say to people, so what robots do you have in your home? Well, I've done that. And they go, I don't have a robot in my home. I said, well, I think you do. And they say, what? I said, well, do you have a washing machine? And they say, oh, yes, I've got a washing machine, but that's not a robot. I said, well, no, it is a robot. And the point is, the most successful robots are the ones that we don't think of as robots anymore. So a drone is a robot, a 3D printer is a robot or a smart machine, an autonomous vehicle. In fact, a normal connected car is a very sophisticated smart machine with hundreds of CPUs in it, controlling, everything that's happening. So it's, there are lots of things out there, lots of smart machines out there hiding in plain sight.
We don't recognize.
You just don't necessarily think of them as that, But so there is a whole family of smart machines. There's a whole family of AI technologies. And then there's a family of modeling technologies called synthetic environments. And in that family, it's got 5 members. It's simulations, emulations, visualizations, digital shadows, and digital twins. And once again, they are very different, they're complementary, but they form a family. And once again, there is an evolutionary cycle in there, in the sense that, a lot of people are talking about digital twins now, and it's in the zeitgeist, and, it's got people's attention, and that's great. I'm a huge fan of digital twins. But unfortunately, the term has now been so hijacked, and poor Henry has had to listen to me bend his ear about this, because, I said, unfortunately, when a lot of people talk about digital twins, they don't mean digital twins. Sometimes what they're talking about is just a static sort of 3D diagram or render of a physical thing in the real world. That's a powerful, thing. It may be very useful. It's not a digital twin, and, the key thing is a digital twin has to have that modeling element. It has to be able to predict the future. It's not just a data store. It's not just a sort of a collection of data about some physical asset, the physical twin. But then the other key thing is, it needs to be connected to its physical twin in both directions. So if we think of an example of, a weather forecasting system, that's a digital shadow. It takes a lot of data in from weather stations around the world. It models it. It predicts the weather in the future, and then we get it on the news, so to speak. That's a digital shadow because the connection is in one direction. What makes a true digital twin, in my terms and in most people's terms, is that then when you take those insights and you use it to control the real world, then you've created a digital twin. So anyway, the point is there is a family there of technologies. What they do is they allow you to understand how complex systems work. They allow you to optimize those systems. They allow you to sort of delve back into the past. They let you predict the future. They let you understand what the implications are of the interventions you want to make on the physical world, whether they're the intended or the unintended consequences. So incredibly important in many areas, including when you want to innovate and model new technologies before they exist. So if you're inventing a new kind of robot or a new kind of smart machine, if you can do the modeling in silico, as it's called, i.e. in a digital model, it's much cheaper and faster and less risky than building prototypes in the physical world. But eventually, once you've sort of hammered out the design and you're confident that it's going to work in this digital model, then you start building the physical prototypes and putting them through their paces. And that's when you start moving on to things like living labs as being environments in which you can do that testing. So there is a whole ecosystem, if you like, that supports this blend of technologies. But the really exciting alchemy happens when you start cooking with all of them together. In fact, coming on to the subject of food, my view on transformative innovation and invention is that it's very much like great cooking. You have to think about the sort of the utensils, so the technologies, the building blocks, the talent, and so forth. You have to think about the utensils, so the tools, the frameworks that allow you to assemble and manipulate those raw ingredients, but the recipes are incredibly important. So the culture, the ways of working, the creativity, the ways of solving problems. So that it's that blend of the ingredients, the utensils, and the recipes, just as it is in cooking, that makes it transformative. And you need, if you really want to get the most out of it, you need to work on all three of those together. So it's a sort of it's an amalgam.
And when you sit with somebody like Henry Dimbleby or with maybe looking at a farm or at a food operator, of course, coming from the extreme high-tech side of the food, like moving the food as most efficiently as possible to our plates and the end consumer, like what do you see when you imagine, I don't know how much time you spend on farms, but is it like, I'm not saying laughable or like you would like imagine what we could do here, or like does it get very interesting for you, or you're thinking, oh my God, this is also really seems like we're in 1950 in some cases, or like what do you feel or sense when you're interacting with the food and agriculture system, if that happens a lot, or if you imagine like an average farm in the UK or an average farm in your area?
So my first journey into agriculture and farming was long before any of what I've just talked about happened. My father, who had been a corporate lawyer all his life, retired and suddenly announced, because he'd been very much involved in the kind of the birth of the Green Party in the UK, and was hugely interested in the concept of organic food and self-sufficiency, which was a kind of a concept that had come out then, and a famous book of the same name by John Seymour, which he and my mother read, and they were captivated by that. And they I was just about to go off to university, and they said, "Oh, we've decided we're going to go and buy, a farm in Wales," and that's what they did. So just when most people, retiring at the age of 70, might have put their feet up and maybe done a bit of gardening, on the allotment. My father and my mother, and indeed all of us in different ways, headed off, to this hill farm in Wales. And it was an extraordinary eye-opener about just how challenging, farming is, especially with animals. It's a 24/7, job, and in all weathers, and with all the unpredictability that weather and conditions bring. And I think
even though we have been getting better at that, but still
we've been getting better. But I can tell you on a hill farm in Wales, it's pretty rugged. You do get some sunshine, but it's snow, wind, and hail is all too common at that altitude, and you end up so it's very challenging. But it was also an amazing sandpit for creativity. So. I used to spend my time building machines, with my eldest brother, welding stuff together, making crop sprayers and making new machines for doing things in the farm. But we were also doing things like building a biogas generator to turn, the pig shit into gas. And anyway, so it was a sandpit, for starting to explore different ways to, in a kind of a very kind of simplistic way, automate aspects of that, but also and optimize it. Although we weren't building, digital twins of it, but so that was my first taste, if you like, and I came away from that, and it's still, I look back on that as some of the sort of the 4 or 5 most precious years of my life, in terms of what I was able to experience there. But also with a huge degree of admiration, if you like, for people who do that, day in, day out, for the whole of their lives. So then obviously, got into food in a different way. But then when Henry, during COVID, asked me to join the advisory board of the National Food Strategy, particularly in terms of offering kind of technology advice, I jumped at it because I just thought it's such an important, it's important to the, at the best of times, but it was incredibly important, during the pandemic. So, but also not just the food system as it is, but the fact that we need to be, finding ways, for it to be more sustainable, both for us as humans in terms of healthy eating, but also in terms of the impact on the planet. And obviously, if anybody listening hasn't read the National Food Strategy, I would commend it to them. It's amazing. But one of the things in there, which I think was chapter 2, was about systems thinking, and was about, and one of the recommendations was around, if you like, the need to create a data ecosystem for the food system, and perhaps come back to the second one, but the first one is important because systems thinking was incredibly important, in terms of Ocado, what we did there, because you need to optimize it in an end-to-end system. But it's also incredibly important in all sorts of systems. The food system is a very complex system of systems, but it sits within a wider set of systems, whether that's energy and transport and logistics and healthcare and so on. So and international trade. So it our everyday lives, are if you like an amalgam of many different kinds of systems, and if we want to understand them better, we model data, and modeling are absolutely key. How we collect the data that we need to build the models, but then building the models and then using those to answer questions, but also to do things like optimizing the behavior of those smart machines we talked about earlier. And then coming back to your question, so when I look now at agriculture, or indeed many other systems, from transport to energy to defense to healthcare, there are extraordinary opportunities, not just for AI, but for smart machines and for modeling and for, remote sensing and the Internet of Things and for living labs, and so that's one of the reasons why one of the first things one of the organizations that I'm government organizations I'm still involved in is called the Robotics Growth Partnership, which advises government on smart machine and robotic technologies. And back in 2022, we authored something called the Cyber Physical Infrastructure Vision, which is really about how we can use that blend of technologies that we've been talking about, but at a national scale. Or as I like to put it, how do we build a better Lego set for the UK, or ultimately for the planet? Because we need to change the way in which we build things, whether that be infrastructure or public services or products, all kinds of products and services, because we need to do it in ways that are, more sustainable, more efficient, and more affordable. So that's one of the things that's really excited me, in recent years, is that idea of how we use all of these different kind of technologies, but at a national scale and ultimately a planetary scale, and that includes. So if we want to zoom back to agriculture, the opportunity, to use automation and optimization to improve yields, to improve sustainability, and if you like, find new ways in which to turn photons from the sun into calories, which is the game that we're really playing, when we grow food, but to find new ways of doing that that are not only healthier in terms of the products, but also kinder to the environment. And one of the challenges we face with that is when you want to compare conventional agriculture with alternative forms of agriculture like vertical farming and algae and lots of other things like that, the problem is that it's not a like for like, and conventional agriculture, as many of your listeners will know, has a lot of hidden externalities. So, whether it's, pollution or soil erosion or effects on flooding or chemicals, pesticides, all of those things have an impact, if you like, on the environment. But when you are working out, if you like, the net cost, if you like, not just to the consumer, but to society, they often don't get taken into account. And therefore, we need to find ways to understand those externalities. And once again, the National Food Strategy talked about that in detail. And one of the ways we can do that is through modeling. We can produce, potentially digital models of a theoretical, if you like, farm or field or whatever it is, part of the agriculture, and model those externalities and understand, or start making a step towards understanding what their true cost is, if you like, in a whole of life sense, so that when you buy an apple, yes, you're buying an apple for, whatever it costs, but what does it cost, if you like, the planet to grow that apple? And what would that be like if it was grown in a different way? And obviously, the whole push towards sustainable agriculture is trying to get to somewhere in between, whereby we can have, the benefits of conventional agriculture, but without some of the current negative unintended consequences.
And because it feels like there's such a powerful tool set, like these three families, and within them, like an immensely powerful tool set, readily available or coming available, or in many cases. But it also feels it's mostly ignored by food and ag. I mean, we see a lot of investments going into ag tech, or we saw, and now it's cooling down a bit. Robotics have a name, but it always feels very superficial in general. Like it doesn't feel part of a much bigger vision. And it sort of seems, I don't know why that is, why food and agriculture hasn't embraced or hasn't at least interacted with like the simplest forms of just modeling one or two farms and seeing what are the externalities, what are the net negative and the net positives that it's producing, etc. Like how do we, if we would change this in management, what would happen without changing it? One of the many issues with farming is you have a harvest every year or even less if you do perennial. And you just the iteration cycle is so long and so slow that it's very, very difficult to imagine or to have a culture of innovation. A lot of this suite of technologies could fix part of that because you could iterate very quickly or you could model and understand what potentially will happen. And yet I don't see people talking about, okay, what would an agriculture system in the UK? I mean, you've done some of that, I think, with the food, but like what could it look like? Or what somebody on the podcast just a few hours ago said, we lack the imagination. Like we cannot even imagine what a food system looks like. And we just stuck in, okay, this just gets worse over time. And let's just like put a few band-aids left and right. Like, what do you feel? What's the blockage there? And is it the mindset? Is it age of farmers? Is it we just don't care too much about the countryside? Like what's the, because the tools are there and seem to be there and only getting better every minute.
So it's a lot of different things. So the first thing I would say is, look, the technology does, is there, but in many cases needs to mature further. Smart machines are getting smarter. They're getting more capable, particularly on the back of AI, not just in terms of the intelligence within them, but the power of AI in the design process, if you like, of the smart machines. So
even before they're built.
Even before they're built.
Really
so in the kind of stage of what you would call computational design, the ability for AIs to come up with new solutions, if you like, for making smart machines smarter and better, often by connecting AIs to simulation models. Because when you put those two together, all sorts of things happen, because the simulation allows the AI to explore the real world. The physical, it understands things like the laws of physics and how things move and gravity and the constraints that come with that. So it's really important that
it's good to know gravity. Otherwise,
yeah, gravity is good. It's kind of difficult. It wastes a lot of energy when you fight it. So as poor old drones know. But the point is you need that blend of not just AI going off, generative AI coming up with all sorts of weird and wonderful solutions which actually wouldn't work in physical. But when you put it connected, and this is what has been happening for instance, in architecture for some time. I mean, you've seen extraordinary buildings that have been built where, the design often has come from an AI, but connected to an engineering model that actually puts constraints, if you like, on the creative juices of the AI to make sure that it is structurally, has structural integrity and could be built and could be maintained and all the other things. So that it's that combination. Well, so there is work to be done in making smart machines smarter and more capable, and that's something that I and others are very much involved in, and we're about to publish the latest version of a strategy for smart machines that sort of takes us out to 2035. So it's kind of work in progress, but that so that's part of it is the, if you like, the evolution of smart machines. But the other part is, as your other podcast was saying, it is the sense of the possible. It is our ability to imagine futures, if you like, where these technologies have been deployed, and what would it look like? What would we want from it? What problems could it solve? What problems might it create? And that for those of us who live and breathe these technologies, it's easier to do some of that, but none of us can do it perfectly. But but for people who don't use these technologies, it's much more difficult, and that's why we need to find ways to share use cases, to share videos, to share models of it, so that people can immerse themselves in those kind of futures and get an idea of, oh, look what they did, over here on this farm or in this, industry or whatever, and how might my business be different or similar to that. And once again, so modeling has a role to play in helping explore, helping people understand and have that sense of the possible.
And I often feel we miss that. Like if we look at a landscape, we look at most landscapes are very degraded and are not full of life, definitely. But somehow, because maybe we've lived there for a long time, or we're used to the landscape without a lot of trees or without a lot of insects, or somehow over time it slowly went down. And like our baseline just has been slipping away, and we're like, this is normal. And somehow it's not normal, or it's at least not how it could be in 10 years or 15 years or whatever cycles we're going through. And so I think there's, apart from managing what we currently have or managing it way smarter, there's a huge potential of, okay, what could it look like? What are the different scenarios? What are different options with climate modeling, with what species actually could live here in 10 years, 15 years? What management we need to manage complex systems, because a farm, we've made them simpler over time, but we probably need to complexify them over time, which brings a lot of challenges. And we have a smaller workforce, and we need more machinery and smart machinery to do that. Like, I don't think many people can even imagine what a farm looks like in 15 years. We sort of think, okay, maybe a smarter tractor and that's sort of it. But of course, it's not going to look like that.
Well, things like autonomous tractors and
but it doesn't have to be
drones
that
for
huge one.
microdosing.
It could be a much smaller one.
Well, yes, but I was going to say that, yes, it's about, the machinery to work on conventional farms and fields and so forth, but the sad reality is that, climate change means that areas that used to be farmed in that way, many of them are becoming, infertile, and it's not about, putting an autonomous tractor on there. Actually, just the soil quality and the amount of water that you can bring, and the kind of crops, if you like, you'd need that would withstand, the perhaps the increased heat. All of that means that we're going to have to find new ways also to grow things in areas that are, would be called extreme environments, if you like, or else they're just going to become deserts. So I think there's a whole area of exploration, for this kind of technology that is about how do you create ways of growing food in controlled conditions, but in a landscape that is perhaps now no longer amenable to conventional agriculture, and people have been starting to do that, using solar power and effectively huge greenhouses in deserts and places like that. And it's and how do you recycle the water, and so that is a whole branch of exploration, but that's going to be very important. So it's not just about bringing technology to bear, on farming as we knew it. It's also going to be about that. But then there's another strand, which is back to the whole thing about how do we turn photons into calories in other ways, which somebody called Ian Boyd, who was also mentioned by Henry, I think, on that podcast that he did, a good friend of ours, has done a huge amount of thinking and in this area, and talks very eloquently about it. And we are going to have to find alternative ways to do that, which obviously some people have been exploring with lab-based meat, and other people have been exploring with, can we turn things like algae, into palatable food? There are many different ways, and other people are trying to grow stuff in bioreactors, particularly because some of those technologies are going to be important if we want to to grow food, on other planets, whether that's the moon or Mars or whatever. So it isn't just about the Earth now. People are thinking very much ahead to ways to do that kind of food creation, if you like, in very hostile conditions. So what I'm trying to say is it's a multi-pronged or multi-strategy approach to how we might solve this very complex problem of sustainable, healthy food production, and to do that, for the whole world. So we've got to make sure that the ways in which we would do it don't, if you like, are sustainable and don't just increase the problems that we have that have led to climate change.
And to ask a few questions, we always like to ask, what would be your main message to the investment world, the financial world, either people investing their own money or other people's money, about this, these technologies or this family of different technologies, but also the work you've been doing? What would be, of course, they let's say we do this on stage and they listen to this, but they also forget and people don't remember a lot of things. If there's one seed or one thing you want them to remember and to really to guide their work through, let's say, what would be the one thing you want them to take away?
Well, I'm not sure I'm going to stick to one, but I'll stick to a few. But I think the first thing I would say is that in my experience, everybody focuses, or not everybody, but many people focus on what I would call the outcomes, the verticals. Whether it's technologies or solutions or sectors or whatever. And of course, those are incredibly important because that's where the results come. But I'm much more interested in what I would call the horizontals, the enabling technologies, the enabling solutions, the things that let you scale, that let you be more efficient, that let you optimize. And we've been talking about some of those. So the modeling, the AI, the smart machines, they're all about things like scalability and efficiency and reproducibility and resilience, and that blend of horizontal technologies that cuts across and supports the verticals often doesn't get enough investment, and it doesn't get enough if you like, in interest, I would say, from governments, and there's an S at the end of that, because it's a recurrent problem, because it's like slow cooking. It takes longer often to build those horizontals, and everybody wants the fast food, the kind of the outcomes, and I think that's got to change, because we do need to build things better, in it. Wherever you look, whether it's services, whether it's products, we need to build better. We need to build for maintainability. We need to build for recycling and reuse. We need to change the materials that we use so that they are more sustainable. And so, once again, it's back to that systems approach. We need to look at it from a systems approach, but we need to change the Lego. We need to change the recipes that we employ, in how we go about building what we call the built environment, which is basically everything that is man-made, person-made, if you like. So it's everything that isn't the natural environment. So, and we've built
and
a
even
lot
a
of
big
it
chunk of that is man-made or managed. So there's
well, exactly, or man-affected. As in, so the natural environment and the built environment have crossed over often in not such positive ways. So that so the first thing I would say is focus on the horizontals. But also, one of the things about the horizontals is they lead to intersectionality. They often cut across. They're the things that connect one industry maybe with another. So solutions in one industry or one sector that you can then steal and adapt to solve problems in another. And I'm an intersectionality nut. I think it's incredibly important. I think, if we stay, I used to say to people when I was at Ocado, working for me, don't go out and hang out with people and build networks with people who work in online grocery. Go off and talk to people who build lawnmowers or nuclear reactors or whatever, because what you may learn in those other areas, you may then be able to bring back, and it may be incredibly powerful, but it's also likely to be a source of novel thought and creation, because if you're in an echo chamber of people doing the same things as you, it's probably just the same old things will go round and round. So intersectionality is very important, and it's very important in innovation and invention. So it's very important to help tackle some of this growing list of exponential challenges that we've made for ourselves as a species. So it's we need to get as many novel ideas into the solutions as possible. And those horizontal technologies are part of the kind of the web, if you like, that connects all those different verticals in the different areas. So that's the next thing I would say is invest in the kind of the tools that let us do things faster and more scalably, but also let us join up the solutions from different areas, so that we're not building everything from scratch. Because obviously the more that we can build shared solutions across different systems, that's good for everybody. It takes cost out. It means we don't have all sorts of different spares. It means we have greater interoperability. But the answer is, you need to design for that. You need to think about that beforehand. And therefore, the more in which there are standards, and the kinds of standards that actually we take for granted in the software world. So open source and cloud has transformed how we do software. Well, we need the equivalent for hardware. We need those same kind of shared solutions for hardware.
And what would you do if you would be on the other side of the table as an investor? Let's say you wake up tomorrow morning and you are in charge of a significant amount of money. We usually say, let's say $1 billion, in this case, pound sterling. I'm not looking for dollar amounts or exact amounts. I'm looking for what are big buckets, what are things you would focus on for a very long-term potential in investment strategy. But if you had to put that kind of money to work, which is a bit of a weird question, I understand, but it's just, I like to ask it because when resources are almost unconstrained, like what do people prioritize and what do they focus on?
Well, I would definitely focus on exactly what I've just been saying, which is those sort of those enabling technologies and solutions to accelerate many different kinds of outcomes. I like to think of them as wormholes. They allow you to perhaps outcompete other players who are doing things in a traditional way. If you can find a wormhole that acts as a shortcut to that, and the most powerful one I've ever come across is modeling, but and in conjunction with AI now, as we've been talking about. So I think that would definitely affect my investment. I think the things that make you go faster and accelerate are incredibly powerful. Secondly, and this has very much affected, if you like, the portfolio of startups I work with. Yes, climate technology in all its shapes and forms is important. One of the challenges is that a lot of typical investment sources don't really like to build or invest in hardware. They prefer digital because it's cheap to build and to distribute, and it's quicker to build and less risky. But unfortunately, most of the things that we need to deal with the challenges in the physical world that we've created, which is not just climate change, it's how do we have affordable and sustainable healthcare around the world? How do we feed everybody around the world? And how do we have better resilience to future pandemics, because we're definitely going to have them. So therefore, that's all going to involve physical interventions in our physical world, and so we're going to need hardware. And so we've got to get better at building it, like we've been talking about, but we've also got to encourage new forms of investment in it. because if we want these technologies, and there are some very exciting, climate technologies emerging, we're going to have to find a way to fund not only their initial research, but their scale up and their adoption,
beyond,
and that is often where they hit trouble, and that is where nation states, I think, need to step in, and sovereign wealth funds and so forth, because it's no longer a challenge, I would argue, for traditional investment. This is the future of our species and this planet that we're playing with here, and therefore, there is really nothing more important, that we could invest in, than the solutions to these kinds of exponential challenges, and we need to get really serious about that.
And I'm not sure. Yeah, if a billion would be enough to unlock.
A billion's definitely not enough there, but maybe what one can start doing with that is trying to nurture, some of those really key emergent climate technologies, and but also maybe do more of the modeling that allows you to demonstrate, if you like, what those different solutions be. And that's kind of what. An area that's always interested me is the whole idea of building Earth twins. How do we build digital twins at a planetary scale of both our man-made systems and our natural environment? How do we collect the data scalably from, on land, in and under the sea, in the air? How do we use space observation and satellites to do that? But building, we need all that to feed the Earth twins, but that's something that a growing number of people are starting to talk about, and there are some interesting projects there, but it's critically important because that we've left it so late to intervene. We can't afford to get it wrong, and I think the last thing I would say is perhaps that in my experience, most innovation, as it's called, and I don't really like the word innovation because I'm much more interested in invention, which is more radical, but because innovation tends to be incremental. But most innovation is focused on playing what I would call the current games a little bit better, and an example of that might be the fact that the fascination at the moment with humanoid robots, which, are incredibly complex, costly machines, basically to try and mimic what humans do, using human tools and human processes with all the limitations that come with those. And, that's about finding a better way to play the current game, of human created products and services. I think the future lies in finding completely new. We need to change the game. We need to, as I've been talking about in this podcast, radically change the way that we build solutions. Because we need to do it faster, but also because we need to do it more sustainably, but to do it with a systems approach. So don't just find ways to automate, if you like, what we've done before, but think about it, from scratch, and think about it at a systems level. So once again, I would want to bring that to everything in that innovation portfolio, thinking, in terms of systems rather than just a set of individual investments.
That's a great point to wrap up, and I want to be conscious of your time, but still ask one final question on the magic wand, which we always ask. But if you can change one thing overnight, what would that be?
I love that film, The Martian, with Matt Damon, as the astronaut stranded on Mars and,
the inventor,
and trying to invent new ways to grow food and survive until he can be rescued. And I think at one point in that film, he says an iconic phrase. He says, "I'm going to have to science the shit out of this," and that's always stuck with me. And I feel, for the reasons I've just been talking about, we've left things so late, as I said, that we're going to have to model the shit out of everything, so I've made that point already, but it doesn't stop there, because one way of looking, at how we run this planet, is that it's like a bunch of squabbling tenants, who haven't been looking after the building and who are now really rather surprised and alarmed that they're about to be evicted. The point is, we've got to find ways to manage this extraordinary planet as a sustainable, connected ecosystem, and the first step there is modeling, but it doesn't stop there. And this is going to bring us full circle to digital twins because as I explained at the start, a true digital twin doesn't just model the physical twin. It helps to optimize and control it. And, the complexity of the world that we live in, and we've seen this with, biodiversity and the unintended consequences of the changes we make, and often we intervene with one part of a food chain and it has, disastrous effects elsewhere. Well, we need to turn that building, going back to that analogy of the squabbling tenants, into a sustainable, managed ecosystem. And I think technology can really help us there. So the magic wand, ultimately is how do we take that step from modeling through to actually managing our planet as this connected ecosystem sustainably and for the long term. And with a much greater level of understanding and ultimately compassion and humility than we have brought to bear in the past.
I think that's a perfect way to wrap up this conversation. I want to thank you so much, Paul, for coming on here and for sharing your journey, your lessons learned, what you're working on now, the potential, the opportunities, and definitely bringing a whole suite of tools into our mindset.
Thank you very much.
Thank you so much for listening all the way to the end. For the show notes and links we discussed in this episode, check out our website, investinginregenerativeagriculture.com/posts. If you like this episode, why not share it with a friend or give us a rating on Apple Podcasts? That really helps. Thanks again and see you next time.